Okay, welcome everybody. So it's time, so we should start. So first of all, thank you very much for coming to this talk, basically Micronaut Dragon Slayer of Spring Boot or just another framework. Thank you very much for choosing this talk. I know there's a lot of talks happening at this exactly same time, a lot of great talks, a lot of great speakers, so thank you for choosing this one. First of all, let me introduce myself. My name is Vladimir Dejanović. This is my Twitter, my mail, my blog, my GitHub account if you want to contact me online or follow me and such. I'm part of professional IT since 2006, and I worked in all kinds of projects and basically technologies over the years. My day job is Senior Director of B2C Technology at PVH. PVH is a fashion tech company behind the brands such as Tommy Hilfiger and Calvin Klein. My night job is founder and leader of Amsterdam Java user group. And beside this, I'm giving talk at conferences, like this one. Also, I'm Java 1 rockstar and Code 1 star. But enough about me. So what this talk is going to be about? First, we're going to talk about motivation for this talk, like why even I had the idea to even give talk like this. Then we're going to actually compare the Micronaut and the Spring Boot, and we're going to use sample examples, so to say. We actually created a small challenge, and I'm going to solve the challenge in both Spring Boot and Micronaut, and then we can compare how good they are. At the end, there will be some time for questions, so if you have any questions, please wait until the end. Before we start, I need to say a few disclaimers. First disclaimer is, I love Spring and I love Spring Boot, and I'm a heavy user of both. So if you came to this talk expecting the rant talk against the Spring and Spring Boot, sorry to disappoint you. Besides this, also what I want to mention is that I'm not involved in developing the Spring or Spring Boot or anything of their ecosystem, so I'm not a contributor in any way. I'm just a user. The similar thing is also from the Micronaut. So I'm not involved into development of Micronaut or anything around the ecosystem of a Micronaut. Again, the same thing. I'm just a user, and hopefully the fact that I don't have stake in any of these two frameworks I should be independent, so to say. The last disclaimer is that basically all the things that I'm going to share with you come from my own personal experience. So don't just believe me without any questions. Always check because your use case might be different than mine. So again, maybe your user experience will look different than mine. So what's the motivation for this talk? Why even why should we even bother with Micronaut and Spring Boot and comparison? Well, it comes from a very simple thing, and that is today, if we want to build anything, basically any Java application or API or anything like that, we have a choice to make. So we can go library toolkit approach, or we can go basically the framework approach. And if we want to go with the libraries and toolkits approach, of course there is the Vertex toolkit for toolkit for building reactive applications, or basically there's a Redpack, the set of libraries for building HTTP applications on JVM stack. Both great options. If, on the other hand, we want to go on the framework approach, well, there's, of course, Jakarta EE, formerly JEE. Then I think everybody basically knows Spring, right? Hopefully. Again, Spring is a big part of our frameworks in the Java ecosystem. And from recently, we also have a Micronaut. But what's the big difference between these two approaches? Well, if we go with the libraries and toolkits approach, basically everything is open to us. So we can basically customize every single thing exactly as we want it, the best to suit our own needs. But it also means that we need to basically think about a lot of things. We need to basically make sure that bits and pieces that we actually take together and assemble an application will work in a good way. With the framework approach, basically somebody already did the hard work for us. So we don't have to worry about all the small bits and pieces. But the problem with the framework is that it's more it's constraining us more. Because again, somebody had a vision, okay, this is the way how you should do the things. Basically, we're going to build all the boilerplate code around it and everything that you basically need. And as long as you stay in that path, with the framework, you're in the perfect place. If you want to go outside of that path, then it's become more a little bit tricky. So what actually people do when they face this challenge? And we all face this challenge every single day when we need to build some new application, right? Well, majority of people go with the framework approach. The reason for that is very simple. You can, from developer point of view, you can very easily and fastly actually assemble some code, basically put it in production, and basically have everything running. It's much easier and faster from developer point of view, because we don't have to worry about every single smaller piece of it. Of course, when we talk about the frameworks, the most popular framework is, of course, Spring and Spring Boot. So the majority of people actually want to take it, are using Spring and Spring Boot. And that shouldn't come as a surprise again, because the Spring and the Spring Boot is a very powerful dragon and a magical beast. It does a lot of crazy stuff for us. It does a lot of magic for us. Whatever you can think of basically to do, there is something in the Spring ecosystem that actually can help you do that without any problems. You just add one dependency and all your problems are solved. So it does a lot of magical stuff for us. It gives us a lot of power, a lot of basically good, nice tools. Also, the user base is very huge. So it means that if you encounter any kind of problem, there's a good chance that somebody also encountered that problem and that maybe they know how to solve it. Or basically there's a blog post or something like that on the internet. But all of this magic doesn't come for free. So there's prices that we need to pay when we use Spring and Spring Boot. So the first price that we need to pay is, of course, memory. And we need to pay with the memory because if you think about how the way the Spring and Spring Boot works, they do a lot of reflections and basically, in the runtime, basically they create all kind of proxies and all this kind of stuff, and like all those objects actually need to live somewhere. So they're going to take a lot of memory. Another thing that we need to pay also in the price is the CPU. Because again, you need to do basically reflections, you need to basically do injections, you do a lot, basically Spring does a lot of stuff for us in runtime. And again, when you do something in runtime, that means we're spending CPU cycles, right? Again, this should also come as a price, that we need to pay price in a startup, because when actually Spring application startups, it needs to do, scan all your code, basically find all dependencies, injections, basically prepare, connect all the bits and pieces, and basically make application which can work, right? So it takes time. Last but not the least is basically GraalVM. So as far as I know, at the moment, Spring doesn't work with GraalVM. And again, this is becoming more and more important because also you probably saw a lot of talks with the frameworks which actually work with GraalVM, and also saw the talks about GraalVM itself. And it's a very cool and good thing to use. So this is a price that unfortunately at the moment with Spring we just can't use. Okay, so is there a solution, right? Is there a solution? Is there something that can give us all the productivity and nice features that basically Spring does, but without any prices to pay? Well, according to the Micronaut team, there is. They say it's a Micronaut. So, to be honest with you, I saw a lot of nice demos about the Micronaut, and I was really amazed. However, all those talks were done by people who are heavily invested in the Micronaut framework. So, of course, they are going to show us all the nice and funny stuff, right? Nobody's going to show you the crappy demo, right? So that's the reason why I say, okay, I want to basically see for myself how they compare. So if I'm a developer and I want to build something, how one to another will compare. And again, like I said, I don't have stake in any of them, so it should be independent. So I say I want to have a small challenge. And the challenge consists of this. I want to be able to build the REST API. That's the first thing. The second thing is I want to have a database, right? So I want to connect to some database, because again, if we don't have a database, then what kind of application we're building? Then I want to have option to basically organize my code in services. So it doesn't have to be called service, but just to allow me that functionality, because then it allows me to actually organize my code in a nicer way. Also, I want to have some kind of way to basically serve the static content and dynamic front end, because again, maybe I want to build the full application in Java. Why not? And last but not the least, I also need security. So if there are security people here, I know security shouldn't be last, but again, we need it. So the good thing is the code for Spring Boot is already online. So this is the URL. So let's look at the code. So if we want to actually solve this problem, what would we do is actually, we would go to start.spring.io, right? And then basically here, okay, cool, this takes some time. And then here we will just add the dependency that we want. So basically we would add, okay, no, not this one. Where's the dependencies? Oh yeah, so here basically we would add web. So we would then add basically db2, no, h2. We would add the JPI, we would add security, we would add time leaf, we would add Lombok because we were lazy people. And basically with this, then we would download the code, and then we would start coding. So I don't have a lot of time, so I'll just show you the already done demo for Spring Boot. So this is how your application would look like. So in this case, we're building a simple bookstore application. So we have a Pojo book. Basically, it doesn't have nothing fancy. I have a data from Lombok to generate all the getters and setters because I'm lazy. Of course, I have an entity. I have a book entity which has an ID and a title, that's it. Then I have a repository to connect to my H2 database instance. Again, in this case, as you see, Spring did all work for me. So I just add annotation repository, say book repository, extends JPI repository for our entity book, type ID long, that's it. Then we have a service. In the service, basically, again, we have just annotation service. We inject book repository. We basically have like get all books, save a book, that's it. On a web, basically, we have a controller, which is simple REST controller. Again, Spring did all work for us, so we just add one annotation, REST controller. We inject basically one resource, service. We on /books, we get all books. Then on /admin/book, we will insert the book. So we just pass the parameter title. So I know, yeah, I'm using get to put the data in the database. Don't do this. This is just for demo purposes because it's easier for me to show. So don't do this in production. Of course, we have a template. So this is just a simple login page just to show, okay, we have some dynamic content. It's done in Timeleaf. We have basically then a simple configuration, which is just going to basically connect /login with my basically template so that I can actually connect those two things. We have a simple web security configuration, so it's just configuration, enable web security. Again, Spring did almost all the work for me. So the only thing that I need to do is add few annotations, extend web security configure adapter. Then basically here I say, okay, /books permit to everybody. In case of /admin something, I want to be authenticated. And that's it. So let's build this code and see how it goes. Hopefully it works, right? Who thinks it's going to work? Wow. That low? Come on, this code was already prepared. Like, if this doesn't work, then I'm like really screwed. Okay, so one thing that I want to show you is we needed 10 seconds to, like 10 and some seconds to actually compile the code. Let's now run the code. And let's see how much time, actually try to remember these numbers. So it's compiling time, 10 seconds. Let's see the startup time. Oh, this is going to be fun now because there's going to be some more password here that I need to remember. Okay, 16 seconds for start, and the password is, okay, this is the password. So Spring Boot also generated the password for me. Okay, cool. So startup time, more than 60 seconds. So if we go here to the localhost, 8080, and we /books, we get nothing, of course, because there's nothing there. So let's add something with our beautiful get. Again, don't do this in production, please. So let's add this book, for example. It's going to say, okay, like you need to authenticate. We say user, the password that basically we remembered, we sign in. Okay, so we now actually added one book. Let's add another book. So we added 2 books. Let's just check if everything works. Cool, so it all works, right? It all works as we expected. Perfect. So Spring Boot done. Let's see actually how we do now with the Micronaut, right? So again, the good thing is the whole code is also already online, so you can check it. But we are now actually going to do live coding. So the first thing that you actually need to understand when we talk about the Micronaut is that there is no start.spring.io. So that doesn't exist. What basically exists is SDK man. And basically, first you need to install SDK man. Once you install this, then you can say basically this SDK list and basically see all the things that are present there. And there is also Micronaut. So basically, to install Micronaut, you just say SDK install Micronaut, right? So this is the command. If you already have installed Micronaut like I have, you can just check which version you have with SDK list and say SDK list Micronaut. And as you can see, basically I have 2 installed, but I'm using at the moment 1.414. So with this, what we actually have basically is like a client command tool, which is mn. And basically here, you have some commands, of course, that you can actually run. So one thing that's very interesting here is you have like different profiles, all those kind of things. So if you say, okay, list profiles. So we see a list profiles. We get different kind of profiles. And one which we are interested in the moment is service. So if we say profile info, and we say service, basically here then you get the long list of all the things which are already there, like done for you. So basically here you have like, like MongoDB, you have like Neo4j, you have Netflix stuff, you have Redis stuff, you have security, you have also somewhere above is Hibernate. Yeah, where's Hibernate? Yeah, Hibernate API. So this is all the things, dependencies that in the start.spring.io we would actually add for the web. Basically, this is all the things that we can add here for the Micronaut. And again, this is the version on my machine, which is outdated. It's constantly being updated with new stuff. So now, in order to create the application, what we need to do is basically we just do this, mn, create app, and then we add the name, let's say book Micronaut, right? That is going to be our name. Hopefully I don't have a directory like that. If you run this, by default, it will create the project, simple empty project with a Gradle. But because I prefer Maven, I just say build Maven. Then we can add features, and we can say Hibernate, GPI, security. Hopefully I didn't do any typos. And we just run this. Okay, the directory already exists. That's not good. So let's just delete it. Let's run it again. It's going to create an empty project. Like I said, hopefully I didn't do any typos, because if I did typos, we're in a big world of problems. Okay. So let's then now go to bookstore Micronaut. Okay, let's be prepared there. Let's now open the code. And let's see actually what we have for free. So what's going to be generated for us out of the box. Okay, so let's see what we actually have here. Okay, this is strange. How we have target? Target shouldn't be there, right? Okay, so first thing first, we also get some tests for free, but I'm just going to delete them because we don't know that, we don't need them anymore at the moment. And again, like who needs tests, right? So again, POM is already generated with all the dependencies. We don't have to look at it now. What's important for us is basically here, you see we get logback already set up by default for us. We have application with all the things set up already for us. So it's like H2 database, all kind of things. There's also security. And at the moment, I'm going to comment security. Then basically here we have some package. So let's rename that package. Okay, so we rename the package. Okay, so now this is done. Now we don't need this directory anymore, so we can delete it, right? Enable auto import, of course. So if you open this, this is basically a very simple just application, and that's like one Java class, and it looks very similar to Spring Boot, right? It's just a starter. Oh yeah, I actually realized that now I made a mistake. So what we need to do, let me actually, first of all, let me just copy the code from the book, because I need actually to add the purges. And I don't want to write all of this code again. So let me just copy paste this one. Okay, so first let's create a purger, because we need write purges. So we need to create a package, purger, new class, Java class, book. Okay, I don't care about this one. So the first thing that you will notice is that here, in this case, I will not have basically the lombok. The reason why I will not have a lombok is because lombok actually generates getters and setters on a runtime. And the Micronaut also gets all its magic in a runtime. So basically, that's why how they can provide you with all the beautiful things that Springs give us, but without the overhead. Because the Spring provides us with magic in a runtime, while the Micronaut actually, my bad, in compile time. So the Micronaut will do it in compile time, also like a Lombok. So if you can actually make work Lombok and the Micronaut both at the same time, and basically to do their magic in the compile time, but it's kind of hassle, so I don't want to deal with that at the moment. So I'll just generate 2 getters and setters. It's like it's not that big of a deal, right? So the next thing is we need to add repository, of course. So let's add package repository. Repository, if I know how to type. Then we can add a new package called book repository, new class book repository. So in this case, we will not have annotation at repository, we will have annotation singleton. And in this case, basically, again, hopefully everybody knows what singleton is, right? So then we need persistent context, yes. Entity context, no, entity manager, yes. Private, and final, application configuration. Let's also make this private. So now what we need to actually do is inject this stuff here. Okay, I need also to add semicolon, or it doesn't work. So there are multiple ways how you can inject stuff in a Micronaut. The way that I'm going to do it here is through the constructor. So I'm going to say just book repository, current session, entity manager, application configuration. And this entity manager is entity manager. This application configuration is application configuration, and that's it. So basically, this is one way how you can inject stuff in a Micronaut. So now we need to add basically get all, right? So it's going to be a list of book get all. So let's import the dependencies. Yes, this is the book. Of course, you don't know what the list is. So we will add transactional from the Micronaut. That's a very important thing because it's going to be read-only. We're going to say read-only equal true. So what here we're going to do is create a basically query, string SQL query is select O from book as O. Then we're going to say entity manager, create query, SQL query for book.class. We of course we need to create this as a variable query is equal. Yes, create local variable. Yes, thank you. And now we just say return query get result list. Yes. And that's it. So basically this is how we actually going to read the data. Now we also need to save the data. So let's say with transactional public, we're going to return the book, save string title, and we're going to say here book is new book, right? Book set title is title. Then we say, okay, let me entity manager persist book, and we return book, and that's it. Repository done. Now let's add service. So again, new package, service. So again, we add book service. And again, the same thing. We don't have annotation service. We just add annotation singleton. Again, we need to basically inject book repository, right? Book repository. Again, we're going to inject it through the constructor. Book service, book repository. Okay, and then we're going to say here this book repository is book repository. Done, injection done. So what we need to provide is again 2 methods. Basically, one is for going to return the list of books. Let's call it find all. It's going to be book return book repository. I called it get all, right? Yeah, I called it get all. Let's import the list because otherwise it's going to complain. And also we're going to say one more where we actually add the book for a string title. And then we just say return book repository, save title, and that's it. Again, service also done. Last but not the least, we also need to add, the controller, right? So we can say new package, controller. So we are going to create new Java class, book controller. And okay, cancel. So in this case, we have annotation controller. So we are going to use annotation controller. Again, we need to inject service, so it's private. Book service. Okay, so again, through the constructor. Book controller, book service. This .book service is book service, right? So this one is injected. Cool, that's done. Now we need basically to create two endpoints. One is /books. Per class, yes. And this is going to return public list command of book. Get all books. So if we just import the book now, we see, okay, and also list, why not? So now we're going to say return book.service, yes, find all, that's it. We need to add one more. Get, it's going to be /admin/book, public book, add book, or however. Then we have basically, we need to add query value, yes. It's going to be called title, and then we say here string title. And we're just going to say return book service, add book title. That's it. So let's just do quick now, let's see if it actually works. Just, sanity check. So if we compile the code, so this is still not full solution, right? We're still missing basically the front end, templating front end, and we're also still missing security. So if you compile code now, the one thing that I'm going to tell you out of the box is it's going to take more time than a Spring Boot. And again, because Spring Boot does the magic in a runtime, Micronaut does all the injections in compile time. So with the Spring Boot, it was 10 seconds. Here is, as you can see, 18 seconds. But let's look now at basically when it startups. So when we go target, book to Micronaut, so this is going to be starting much faster than a Spring Boot. Because again, Spring Boot, during the startup, does a lot of injections and all those kind of things. Micronaut doesn't do it for us. So as you can see, it started in 7 seconds. Again, this is still not a full solution. So let's just see if it actually works. So if we go here basically on a same URL, localhost books, we shouldn't get anything because there is nothing there, yes. And if we try to add a book, at the moment it's going to pass. It should pass at least because we don't have protection. So yeah, we added a book. And if we go again, books. Yeah, so there is a book. Cool, so it works. So now let's actually finish our code. So first thing first, let's add the security. In order to add security let's add everything. So if I want to add the templating engine, I need to add few things in the dependencies. So first thing first, I need to add here dependency, and I want to say Micronaut, views, basically that's it. Then also I need to add the templating engine, which is again dependency, timeleaf, and we're going to add version 3. Yeah, I think this is the one. Hopefully this correct one. The next thing, what we're going to do is in resources we are going to create a directory called views, because it expects all the templates engine basically to be there. So now we created the views. I'm not going to be honest with you, I'm not going to write the views now because there it's boring. So there's home. I'm going to put it in source, resource, main, resources, views. And there's also login. No, it's auth. Yeah, it's authentication. Also what I'm going to copy also some controllers because I want to also use time with that. I'm going to show you all this code. Java, okay, controller, yes. And there's also should be one more. I think it's called home. Home controller, yes. So basically now we added some code. So let's see actually what we added. So in views, I added very simple home page written in time-leaf. So again, it's nothing like really magical about it. Also in authentication, also I added just one simple basically time-leaf, basically simple login page. So I don't want to spend time on that. In controllers, basically I added the home controller to actually connect my template with my view. And I also added the login controller. Again, the same thing, to connect basically my URL with the template engine. So now I need to go to application. I need to uncomment the security, which we actually commented out. Also, I also need to uncomment. Then I need to basically change this URL to login/authentication failed. The next thing that I need to do is actually now I need to protect my book controller. So I need to basically secure this. So I'm secured it with basically security rule. Rule is anonymous because it actually should be open to anybody. And like other, basically when we add the book, here we want to basically have like authenticated. Again, security rule authenticated. This is one way how you can secure basically your application. There are multiple ways. You can also add all this logic, what's protected by which roles and everything like that in the YAML file. You can also use JSRs directly from the Java itself spec for security. Or you can basically use Micronaut annotation. So there's like multiple ways with security. So now we protected ourselves, but we still need to basically add one more thing, and that is actually we need to provide with some way to authenticate. So let's create a new package controller, and basically let's create here simple authentication provider. Authentication provider. Okay, we don't want to edit. So again, we add as a singleton. Here we're going to implement authentication provider. Yes. Then we're going to basically implement one method. Yes. So what we're going to do here is we are going to say if, and then we say authentication request, get identity, this dot equals user, and authentication request, get secret, equals password. So this is very hard to guess, right? We're just going to return flowable just of new user details, and we're going to provide username as a user and new command. You see, it's not always array list. Of course, we need to import this. That's it. In the case we provide the wrong password, we're just going to return flowable just new authentication failed. Yes. And this should be it. So let's now try to compile the full solution. And again, it should take more time than Spring Boot, right? Because even like not the full solution took more time than Spring Boot. So let's see how this goes. Again, Micronaut does a lot of stuff for us in compile time. It checks all the dependencies, it checks all the injections, and basically put them all together. So it's like took 19 seconds. So let's see if the runtime is still better. In theory, it should be, because again, like all the injections, everything is still done. So basically, it started in 7 seconds. So almost no change at all. Again, and if you remember, Spring Boot took like 16 seconds. So if we now go to /books, there will be no books because we don't have anything in our database, right? So if now we try to actually add book, admin, book, title, let's say 1Q84, why not? It's going to say, okay, you need to log in. So you see this beautiful, dynamic page that we have. So we say user, password, we log in. Okay, so we now logged in. So if we now try again, admin, book, title, dance. Basically, we added one. We can also add pinball. Again, we also added one more book. So if we go and /now check the books, yeah, it all works. So, so let's look at basically some results that actually how it took on my laptop. So again, like this is my laptop, my environment, your use case may be different. So if you look at the build time, Spring roughly took about 10 seconds. Micronaut took roughly about 21 seconds. Okay, in this case it was 18 seconds, but doesn't matter. Again, Micronaut needs more time in compile time because it does all the scanning of your code, all injections, all dependencies, everything is done in compile time compared to the runtime of a Spring Boot. The startup time, well, in the case of a Spring Boot, it took roughly around 15 seconds. Micronaut around 7.1 seconds. Again, this shouldn't come as a surprise because all the magic that happens in a Spring happens in a runtime, and basically the startup is really big part where actually it does scanning all the code, all the dependencies, all injections and everything. In case of the Micronaut, it doesn't have to do that, so Micronaut, of course, is faster. So how it comes, basically look. So in startup time, Micronaut wins. Let's look now at the memory consumption. So roughly, again, this use case that I showed you with the Spring Boot took, on my machine, 190 megabytes. Again, I just started this with a simple java-jar file. That's it. So I didn't provide any special, flags or anything. Basically, okay, use this amount of heap or anything. I just say, okay, you just go, and I'm not going to influence you in any single way. So Spring Boot took 190 megabytes. The same condition with the Micronaut is 80 megabytes. So I would say the Micronaut wins, right? Because it took much, much, much less memory than the Spring Boot. Okay, then let's look at CPU. How the CPU compares. Well, this is actually, I basically started my Spring Boot application. I connected the visual VM, and I run a fake load test. And this is basically what I got in visual VM for Spring Boot. And then I did the same thing for Micronaut, and I got this. So which one wins? Well, basically, I would say that my use case probably isn't the best thing to actually demonstrate is one or the other better. But again, if I think about the ways actually, okay, how the Spring Boot works, how the Micronaut works, I would say that its logical conclusion would be that Micronaut would win. But again, on my use case, I can say, okay, you see, here's the proof. Now the big one, the Grell VM. Well, I didn't show you the demo for that because, again, like I said, there is no demo for Spring Boot, as far as I know. And there's multiple talks and demos about, Micronaut and Grell VM, so I didn't want to spend time with that. But yeah, Micronaut wins because, again, it works out of the box with the Grell VM because everything, all dependencies, everything is done in compile time. There is no any problems. Now we come to the most important part, how we actually compare with the challenge. So which one is better, right? Well, I would say that both were great because with both of them, in a very short amount of time, you can actually solve all the problems, right? So you saw me coding live in Micronaut, maybe 20 minutes, 25 minutes, and I did everything. You can also do similar thing in Spring Boot, maybe even smaller, but it's basically very fast to do it in both of them. But I would say that Spring Boot was just tiny better. The only very, very small tiny better. And the only reason why I would say that is that from the developer point of view, if you look at Spring Boot, and if you look repository, and you look at Micronaut repository, Spring Boot repository looks much, much nicer. Which one performs better, which one is actually better to have, that's a different discussion. But from purely development point of view, in the Spring Boot, I just add one annotation where I just say, okay, implement it, basically extend this framework and the interface, and that's it. The Spring Boot does all the magic for me. In the case of a Micronaut, I had to write all this code. So that's the only reason why I would say, it's for a hair or of a dog, basically the Spring Boot wins here. But it's very, very, very tiny. So it's almost you can ignore it. So what's the conclusion, right? Because we started this talk with, let's say, basically see, is Micronaut really much better? Is Micronaut really the killer of a Spring Boot? If you have today running application written in the Spring or the Spring Boot, should you throw it away and completely rewrite it in the Micronaut? And my answer for you to that would be, keep your current code base as it is. So don't rewrite whatever you have, and whatever you have, basically, it doesn't have to be a Spring, but don't rewrite it in a Micronaut just to rewrite it, unless you have a really, really good reason. Because again, rewriting the code doesn't always give us the benefits, and it's definitely going to cost us time and resources. So keep your current code base from your project, whatever it is, now as it is, unless you have really big problems. But if you're actually starting with a new project, well, then I would say definitely consider Micronaut. Again, for my use case, basically, all the existing projects, definitely I'm not going to rewrite in Micronaut. But if you start something new, the Micronaut is very high on my list because it gives me productivity of all the frameworks that we like. It's very easy and fast to actually do stuff, and it's very performant. It's mind-blowing. Also, the amount of basically features that already exist is just ridiculous. So you already have Kafka, you already have GraphQL, you already have messaging. Basically, you already have gRPC. Basically, every single service discovery, you name it, they have it. So basically, every single day, the ecosystem is rapidly growing. The documentation is phenomenal. Basically, you can just go read guides and everything, and tutorials, documentation, and just you will be able to solve all your problems. So it's extremely good thing to consider for new projects. Thank you.